Can you hear me?
Yes, I can.
Okay.
All right. So what are we going to do tonight?
The first thing here, I don't think it's going to really relate to the rest of the homework. It's about me, so might as well start with it.
Okay.
So the directions are to express the function as a sinusoid in the form y equals a sine, parenthesis bx plus c.
Bx plus c?
Yeah.
Okay.
And the problem is y equals 3 cosine 2x minus 2 sine 2x.
Minus 2 sine 2x?
Yeah.
Huh. Well, let me think for a moment. If we use the double angle identity, we can express cosine of 2x as nothing but sine squared. And we can express sine of 2x as sine and cosine. Gosh, how are we going to do this? Well, let's start by seeing if we can turn the cosine of 2x into nothing but sine. See what happens. What's the identity for the cosine of 2x in terms of sine? There's three identities. One is cosine squared minus sine squared. I believe the identity is 1 minus 2 sine squared. Huh? Let me grab my book. I don't want to start off using the wrong identity, so let me look it up.
Cosine 2x, there are 3 possible.
Yeah, which one is just the sines?
Just the sine, 1 minus 2 sine squared x.
Okay, like I've written it. Okay. Now, does that help things? Yeah, it kind of does, I think. Let me think for a second. So if we distribute this, we get 3 minus 6 sine squared x minus 2 sine 2x. If I were to write sine of 2x as 2 sine cosine, it would be 2 sine x cosine x.
You have 22 sine there.
Yeah, I mean this, actually. Now I could write cosine x as the square root of 1 minus sine squared x. Well, let's see what happens. I haven't run into a problem like this, I don't think, ever. But let's just follow our nose here and see if we can come down to that other equation there. All right, so this would be 4 sine x, and in place of cosine x, I'm going to write the square root of 1 minus sine squared x, which is what cosine of x is equal to. That doesn't help at all. Wow. Any clues or hints that they give you on this? Is this in the chapter on the double angle identity? Must be.
The page right before it is still talking about sine and sum are different.
Okay. That actually might be... no, that's not helpful either. Unless we... yeah, no. Well, let's see. Well, hold on a moment. This is the sum. Let's see if we can backtrack this here. Well, let's take a different... this approach doesn't seem to be getting me anywhere. I got it all as a sine, but simplifying this and putting it into that format doesn't look like it's going to be very effective. So let's assume that we're looking at the sine of the sum. In other words, if we start with this and we turn it into a, and then this whole sine of bx plus c is sine of bx cosine of c plus sine of c cosine of bx. Just using the difference, sum and difference formula for that. And is that helpful?
I'm looking at it. So in the directions for this, it says that an example here is, let's see. Yeah, that's actually exactly it right there. What they have different numbers here. They have 2 sine x plus 5 cosine x equals a sine bx cosine c plus cosine bx sine c.
So they are using the sum and difference formula.
Yeah.
Okay. So how can I take this and relate it to this? I guess I could say
next thing from there is that equals parenthesis a cosine c and parenthesis sine bx plus parenthesis a sine c parenthesis cosine bx.
and then that relates exactly to that, huh? So they distribute it. So you're saying the next step should be
A cosine c
sine bx plus a cosine bx sine c.
Well, there are some parentheses in there. It's a cosine c is in parentheses, like the first part. and then it's sine bx.
Okay, so you're saying they wrote it A cosine C sine bx.
Yeah, a cosine c is in parentheses. Yeah. A cosine c in parentheses.
Well, I don't have a cosine C over here.
Oh, sorry, a sine c.
Okay.
And then cosine bx.
Okay. I think I'm kind of getting where they're headed here. So B is going to be 2, and A cosine C must be 3, and A sine C must be 2. Except there's a negative sign there instead of a plus sign, which means that that's okay. In other words, if I had that, it would result in this. Yeah, okay. I think I'm on the way here towards solving it. In other words, if I start with A sine of bx minus c and use the difference formula, I get down to here. Okay? Now, that is the same as the negative of this. In other words, I can now put a negative sign out front there, and what I now have is A sine C cosine bx minus A cosine C sine bx. You see how I get to that step? In other words, I want to switch these two things because the formula they gave us, the cosine of 2x, is the first thing. So I've taken my standard formula, bx minus c, and turned it into what you see on the bottom. And what you see on the bottom looks very much like that, where A sine C would be negative 3. So A sine C would equal negative 3. This 3 right here, and this negative sign. And A cosine C would equal 2. I still don't see how that is going to allow me to put it back into a single sinusoid function. Oh, hold it. Yes, I do. In other words, this is that bottom line becomes that. In other words, if I gave you the bottom line, you could put that back together again and write it like my top line. Okay? So what we want to do is take this line here and put it back together again as a top line. And I think the bottom line you see where a sine c has to be 3.
Yeah.
Cosine of bx, b has to be 2. A cosine of c has to be this 2. And b is 2 there. So if a sine of c is 3 and a cosine of c is 2, this thing becomes sine of c plus bx. If I said the sine of c plus bx, you'd say that's the sine of c cosine of bx plus the cosine of c sine of bx. So working backwards, there's the A. No, there's the A right there. And C, wow. If I feel like I'm almost seeing it, but not quite. Yeah, that's what we started with.
Yeah. We're trying to get that equation to look like that, right?
Right, exactly. In other words, how do we take your equation here and make it look like the sum and difference identity? Well, 3 would have to be the sine of C. So A times the sine of C would have to be 3, which makes C equal, which makes A minus 3 over sine C. Wow. That's the sine of C right here. In other words, if that was the sine of C and if this was the cosine of C, we would be there almost. What to do with the 3 and the 2? What does it have to be? It has to be y equals sum A times the sine of 2x minus, if I make that a 3, yeah, let's sorry to struggle so much with this thing, but okay. I think this is on the right track here. What if we had this equation right here, and we use the sum and difference? That gives me A times the sine of 2x cosine of 3 minus sine of 3 cosine of 2x. Which isn't exactly what we have, but it's close. Well, we need to switch them. Yes. Let me think for just a second. So we got the cosine. If that's true, then A has to be minus 3 over sine C. That surely isn't going to be the answer. It's minus 3 over sine C. Let's go on to your next one, Daniel. I'm struggling so much on this one, I'm not quite sure how to put it back together. Probably the way to do it is to look at the example you have in your book and try to do this problem exactly the way they do the example problem in your book, only using this set of numbers. It sounds like they gave you one that was pretty similar.
Yeah.
You want to go to a different problem, or do you want to go over the example? If you give me the step-by-step process of the example, I bet I can figure out how they do it.
Yeah, there's a lot of steps. Do you want me to just send a picture of the?
Yeah, that'd be better. You have my email address still, David Cowan, 1949. Yeah, send me a picture of it, because I think I can probably figure it out if I'm looking at their example. There's something about putting that A cosine of C in parentheses. Why they're doing that, I'm not sure. Give me a holler when you've sent it.
You're David Cohen 1949 at Gmail.
Yes, gmail.com. Is it just one page?
Yeah.
Okay.
Alright, just sent it.
All right. Let's see if we can figure this out. Oh, okay. All right. Okay. So they're comparing coefficients to solve it. I knew I was doing something wrong, that I was missing. So they take our function what is it again? 3 cosine?
3 cosine 2x minus 2 sine 2x.
And we're going to set that equal to this. A times the sine of bx cosine c minus plus. Yeah, if I'm trying to get it into that formula, I got to use the plot. Plus cosine of bx sine c. Okay. And they multiply, so now they got this equals a cosine c times the sine of bx plus a sine c times the cosine of bx. And now comparing coefficients, we see that b is 1. Well, in our case, b is 2. And a cosine of c is 3, and a sine of c is minus 2. How do they get this step here? Oh, because a cosine of c, they're going to square everything now. Okay. So we have a cosine of c is equal, we have b equals 1, 2. We have a cosine of c equals minus 2. And we have a sine of c equals plus 3. So if we square, in other words, is all they're doing here is this is equal to 2 and this is equal to 5. So 2 squared plus 5 squared equals 2 squared plus 5 squared. So if we do the same thing, we're going to get a squared cosine squared c plus a squared sine squared c equals 4 plus 9, 13. I can factor out the a squared, leaving behind a cosine squared of c plus sine squared of c, which is 1. So a equals the square root plus or minus the square root of 13. Does that give us our answer? If we choose a, the positive a, then cosine of c is 2 over, okay, because we've solved for a. Okay, so cosine of c is going to be minus 2 over the square root of 13. The sine of c is going to be 3 over the square root of 13. we can identify an acute angle C with those specifications as either the inverse cosine of that. Okay, so C is clearly the inverse cosine of that, or the inverse sine of that. They're both the same angle. So an exact sinusoid is going to be, oh, you left off the bottom. What goes below this?
So that is equals square root of 29 parenthesis x plus inverse cosine.
Okay, yeah, C is the inverse cosine. Okay, I get it now. I figured it was going to be something strange like that. Okay, so we're going to have f of x equals a, which in our case came out to be square root of 29. No, excuse me, that's their case. Our case, a came out to be square root of 13. Times the sine of 2x plus c, and c is the inverse cosine of 2 over root 13. There you go. Now, the true test is, I mean, this should be the answer, I think. I may have gotten my signs wrong or done the arithmetic incorrectly. But this does it like they did their example, I think. I can't see the bottom, but I can see what, I know that B is 2 in our case. I know that A is root 13, and C is merely defined as the inverse cosine of that. In other words, we know that the cosine of C was 3 over root 13, so C must be the inverse cosine, or 2 over root 13.
I'm looking at the picture that I took, and it should be, can you like scroll down a few?
Oh, yes. I'm sorry. I thought that it wasn't on there, but it is on there, yeah. Okay, see what they've done? A, they figured out, was root 29. The sine of 1x, in their case, because B was 1, plus the inverse, yes, I've never seen anything like this. That's pretty clever. I like what they've done there. Of that, or square root of 29 times the sine of x plus the inverse sine of that. Now, we're right, but I was not 100% certain that I was using the right numbers for the right letters here. But we're real close. You still there, Daniel? I'm getting audio problems from my GoToMeeting, but that shouldn't affect our audio because we're on audio using Google Phone.
Yeah.
Do you see what's going on here? Do you understand it?
Kind of.
I can start from the top and work through it and make sure we get the exact numbers correct. But it's either well, this has to be square root of 13, because when you take A cosine C and A sine C and square them both, one is a +2 and the other is a 3. So you're going to have square root of 13 for A. And the cosine of C has to be minus 2 over root 13. So this might be a minus sign right here. Now, just real quick, let's assume we had this, and using the sum and difference rule, see if we can get it back to the function we were given. Okay? Let's just try it. It won't take long. The sine of 2x minus the inverse cosine of 2 over 13 should be, let's see, I got this square root of 13 way out here. Now I'm going to put this in terms of sine of 2x cosine of that, which is 2. In other words, the cosine of the inverse cosine is just this number. So that becomes a minus 2 over root 13. Yeah, this works. And then minus the cosine of 2x sine of inverse cosine of 2 over root 13 and notice that we're getting very close to what we started with. In other words, this root 13 is going to cancel out with that root 13. This is a minus, so we're going to end up with cosine 2x times, what is the sine of the inverse cosine? That's the question. The sine of the inverse cosine. That has to be oh, this part over here has to be different. This has to be the sine of, oh, this is, this can be either the inverse cosine of 2 over root 13, or it can be the inverse sine of 3 over root 13. Yeah. In other words, this part right here, this inverse cosine, notice in the example here they say that the inverse cosine of 2 over root 29 is the same as the inverse sine of 5 over root 29. Well, we can do the same thing. We can say the inverse cosine of 2 over root 13 is the same as the inverse sine of 3 over root 13. And now everything turns into what we started with. We've got 3 cosine of 2x minus 2 sine of 2x. Is that not what we started with?
Yep.
So this is the answer. Or I could even make that read inverse sine of 3 over root 13. So there's 2 answers, but this is certainly one of them. just like they gave two answers, or, and replace the inverse cosine with inverse sine. Wow, what a brute that problem is. I've never done a problem like that. It's a little bit like partial fractions. When you decouple a partial fraction and you equate the coefficients. It's kind of what you do here, but there's a lot that has to be done here. Wow. You have to gather that together, and then you got to square both sides so that you can pull out the cosine squared plus sine squared, turn that into 1. Yeah, there's a lot going on there. All right. What else you got? I could even do another one of those, I'm pretty sure.
Well, luckily the next one isn't like that.
Okay. Now that I can do it, sure. What's the next one?
Alright. So, it says, write the expression as one involving only sine theta and cosine theta.
Okay.
The first, actually it's the only one of those, sine 2 theta plus cosine 2 theta.
Well, that's pretty straightforward. What's sine 2 theta equal to?
That'd be just sine theta plus theta.
It's actually that. In other words, just using the only identity they give you for sine of 2 theta. That's this part here.
Oh.
Plus cosine of 2 theta, I can use most anything. I can use cosine squared theta minus sine squared theta. So there's one answer. They said write it as a function of just sine theta or cosine theta, right?
Yeah.
Well, that works. I could also use any of the other two identities for cosine of 2 theta. I'm still going to end up with functions that are either sine theta or cosine theta. Okay?
Okay. Next one. Prove the identity.
Okay.
Cosine 6x equals 2 cosine squared 3x minus 1.
Cosine squared of 3x minus 1 like that?
Without the parentheses, but like there aren't any parentheses in it.
Okay, no, that's fine. But the minus 1 is not, it's cosine squared of 3x.
Yeah.
Minus 1. Okay. Well, let's see. The cosine of 6x is the same as the cosine of 2 times 3x. Right? And one of the cosine double angle identities is this one. So in my case, theta is 3x, right? In other words, this 2 is this 2. This 3x is that theta. So when I use the double angle identity, I get 2 cosine squared of theta, which is 3x, minus 1. So you can prove this identity by just turning 6x into 2 times 3x and then use the double angle identity. Did you follow me on that?
Yeah.
Okay.
Next one.
Boy, that was one that if you start off in the wrong direction on this, you could really get lost.
Yeah.
But that's the case of verifying trig identities. That's really the case with all of them. If you start off on the wrong path, you can get lost in the woods and have to go back and restart it from scratch at the beginning again. Luckily, that one I just kind of saw that 6x was 2 times 3x, and so I could use the double angle identity.
Okay.
What else you got?
Another proof of the identity.
Okay.
Sine 3x equals parentheses sine x and parentheses. Then a new parenthesis 3 minus 4 sine squared x.
Okay. Well, let's see. The sine of 3x could be the sine of 2x plus x. And now, if I use my sum and difference formula, that becomes the sine of 2x cosine x plus the sine of x cosine 2x. Okay? Now, so far, sine of 3x is equal to all of this over here. And now I'm going to use my double angle identity to change the sine of 2x into 2 sine x cosine x times this cosine x plus sine x, and now I've got to use an identity for that, and I see some squareds in there, so I'm going to use the let's see, this is going to become cosine squared x. So I think I want to use the cosine squared identity. Cosine of 2x is equal to what?
That be the square root
2.
of...
No, it's, what was the third identity? You gave it to me just a second ago. What's the identity that it uses cosine squared? It's, I think, 2 cosine squared x minus 1? Is that the identity for cosine of 2x? Or is it 1 minus that? No, I think it's this.
Yeah, cosine 2x equals 2 cosine squared x minus 1.
Okay. So far we got sine of 3x equals everything on my right side, correct?
Yep.
Now all we got to do is turn that right side into this right side. Well, I can certainly see that I can factor out a sine x. So what does that give me? If I factor out a sine x, I'm left with 2 cosine squared x plus 2 cosine squared x minus 1. Well, that's 4 cosine squared x minus 1. How do they get 3 minus 4 sine squared? Ah, okay. No, we're getting someplace here. Let's see. Did I do all my math right? Yeah, let's see. I factored out a sine x, leaving behind 2 cosine squared x plus this all, which is 2 cosine squared x minus 1. So now I've got sine x times 4 cosine squared x minus 1, and cosine squared x is 1 minus sine squared x. So now I have sine x 4 times 1 minus sine squared x minus 1. Now I've got sine x times 4 minus 4 sine squared x minus 1 equals sine x times 3 minus 4 sine squared x, which is what we were trying to prove. And I did it using the sum and difference to turn sine 3x into sine 2x plus x. And then I used the sum and difference on that to get that. And then I used the identities for sine of 2x to get this part. In other words, turn that into this. I used the identity for the cosine of 2x to turn that into this. And I just distribute and use the cosine squared identity of 1 minus sine squared x, and the whole thing turns into that.
Okay.
So there's 3 identities. You need the sum and difference for the sine, you need the identity for sine of 2x, and you need the identity for cosine of 2x. And actually, if I'd have used the other identity for cosine of 2x, I would have saved myself a step. In other words, when I substitute for this cosine of 2x, and I used 2 cosine squared x minus 1, I'd have been better off using the 1 minus 2 sine squared x. Then I wouldn't have had to resubstitute it once I get to this step here. I'd have been in sine squared already. I would have saved myself at least one step if I'd have used the other identity. So all of these are kind of the same. They're harder than regular trig verifying problems because these make you use the sum and difference and the double angle identities. Whereas usually when you're working on verifying trig identities, you're only using those first 11 trig identities. You're not using sum and difference and double angle, whereas these you have to use those. Okay, you got another one? I'm getting the hang of it now.
Yes. Last one, well, it's not proving anymore, so.
Okay, well, that's all right. What's the last one?
Solve algebraically for exact solutions
Okay.
in the interval of 0 to 2 pi.
Okay.
And it is cosine 2x plus 2 sine x equals 0.
Okay. Here, we want to turn that into sine, because then we will have an equation that has nothing but sines in it, and we'll be able to factor it and solve it easily. Well, the identity for that is 1 minus 2 sine squared x. plus 2 sine x equals 0. Well, this is a quadratic. First of all, let me get it in a format where the squared term has a positive coefficient, so I'm going to divide every term by minus 1 to come up with 2 sine squared x minus 2 sine x minus 1 equals 0. Now that factors just like a quadratic. You factor it just like you would factor 2x squared minus 2x minus 1.
Okay.
Let's see, the minus doesn't factor nicely though. No, it doesn't factor nicely, does it? Is that the right identity for cosine of 2x? Here, let me look it up. I don't know why that one gives me trouble, but it does.
1 and 2 sine squared x, so yeah, you call that.
1 minus 2 sine squared x. Okay. So, plus 2 sine x. Okay, so what that tells me is that this is correct. You with me?
Yeah.
Also doesn't factor nicely. So how do I solve this?
You need to use the quadratic equation.
You do. So, sine x, not x, but sine x equals minus b plus or minus square root of 4 minus 4 times 2 times minus 1 all over 4. So what is this? 2 plus or minus square root of 12 all over 4. So that's equal to 2 plus or minus 2 root 3 all over 4. So it's equal to 1 plus or minus root 3 all over 2. That is the sine of x. Well, if I use the plus value, I get the sine of x as a number greater than 1. Because root 3 is like 1.7. So if I have 1 plus 1.7 divided by 2, I get a number greater than 1. Impossible. So I can't use the plus. I can only use the minus. So now we got sine of x equals, well, 1 minus 1.7 is minus 0.7 divided by 2. X is the inverse sine of minus root 3 over 2. Not minus root 3. Minus root 1 minus root 3. Or just 1 minus root 3. You have your calculator?
Yeah.
Here, I have mine. You have the TI-83, right?
84.
Okay, this one right here.
Yeah.
So, what do I want here? I want the inverse sine of 1 minus root 3 divided by 2. And I want inverse sine of 1 minus, oh God, where's the, okay, here we go, root 3 hold on, delete, back, delete, okay, 1 minus root, oh, it puts a parentheses there automatically, 3 in parentheses, another parentheses, good God, divided by 2, holy smokes, I gotta, yeah, divided by 2, but I need a third set of parentheses there. I can't get to this spot to put a second set of parentheses in there. Oh, gosh. Let me do it on Wolfram Alpha so I can at least see the feedback to make sure I'm getting it in there properly. I want the arc sine of 1 minus root 3, which is 3 raised to the 0.5 power, and I want all of that to be divided by 2. Let's see if I got the right number of parentheses here. There you go. In radians, or it's minus 21 degrees. And that only gives you the fourth quadrant answer. They wanted all the answers in 0 to 2 pi. So minus 21 degrees is the fourth quadrant answer, but there's also a third quadrant answer. And the third quadrant answer would be 180 plus 21, 201.47. So there's 2 answers, and only 2. See how we got it?
Yeah.
Well, let's just clarify why we got 2 answers here. In other words, I'm basically taking the inverse sine of approximately negative 0.7 divided by 2. Okay? That gives you, whenever you use your calculator to do the inverse sine or cosine, you only get the principal value. And it gave us the fourth quadrant answer, which is the principal value for inverse sine. It gave us minus 21.7 degrees. Okay? Well, that's a fourth quadrant angle. But there's also a third quadrant angle. In other words, if I took the sine of minus 21.7 degrees, I would get this answer. But also, if I take the sine of 201.7 degrees, that's going to be the same thing as the sine of 21.7, only it's negative because it's in the third quadrant. So that is an answer. In other words, the inverse sine of this number is 2 things. It's minus 21.7 degrees. It's also the third quadrant answer of that. All right. Wow. These are some tough trig questions. What kind of a trig class is this? Is this an honors pre-calc trig?
Yeah.
Okay, that explains it a little bit. I didn't know that. Okay, that's why I don't see these very often. Yeah, because it's only going to be an honors class that gets into this level of trig.
Yeah.
Yeah. But the basic is, if you can factor this, it's relatively easy to solve. But if you have to use the quadratic formula, the secret to using the quadratic formula here is knowing that it's not x equals minus b plus or minus. It's sine x equals all of that. In other words, it's real easy to make that mistake right there.
Oh, yeah.
But it's sine x equals the quadratic formula. And then, once you get a number, you have to solve for x by taking the inverse sign of whatever number you got on the right side.
All right.
All right, Daniel. I will talk to you next Tuesday night.
All right.
All right, bye-bye.